The Gluware suite of applications work to give you complete control of your network, from onboarding and insight to compliance and full automation. Network Robotic Process Automation, the capstone application, allows one to build workflows that automate operational processes, and TitanAI significantly accelerates automation builds. In this video, I'll be demonstrating a Gluware auto remediation workflow. This workflow will allow us to detect unauthorized configuration changes. In this example, we're going to make an unauthorized change to a monitored device. The device will generate a syslog event. Splunk will detect the event in real time and then trigger a Gluware workflow through an API call. The workflow will capture a configuration snapshot, compare the configuration against the approved standard, detect and evaluate configuration drift, then run a Gluware audit policy on the affected device. If the audit fails, the workflow will then automatically provision in the correct configuration. And finally, we'll verify that the device is returned to compliance. This is the Gluware Network Robotic Process Automation Workflow Library. The workflow library contains a collection of all of the workflows that have been built in a given organization. It's worth pointing out that a workflow is nothing more than a collection of Gluware automation tasks that are configured and arranged in a specific order. Let's examine the properties of the workflow that we'll be demonstrating today. Every workflow is an API endpoint in Gluware. This is the specific URL required to run this workflow. Now, some workflows contain input parameters, and these can be defined in the workflow itself. In this particular example, we want to run this check against one specific device, the device that where the configuration terminal was modified, or the configuration was modified. And so we want to filter on the device name. The Splunk alert actually contains the device name in the message, so we're able to extract it from there and run a Gluware workflow with this input parameter. Let's take a look at the workflow. Now, for those of you who are not familiar with Network Robotic Process Automation, or RPA for short, the RPA work pane, which is this space here, contains a timeline. And what we do is we search the task library for the Gluware task that we want, select it, and drag it onto the timeline. Now, some of these tasks require configuration. In this particular task, the filter targets task, I want to filter the workflow to run only on the device that matches the input parameter that I provided you earlier, the device name that I showed you earlier, I should say. Now, some tasks require configuration. In the filter target tasks, I'm specifying that I want the device that I want this workflow to run only on the given device. In other words, the device that was in the alert. And after filtering on just that device, we want to capture a configuration snapshot. After a configuration snapshot has been captured, I want to evaluate if there is drift. If there is drift, then I want to run an audit policy. And that audit policy will check the configuration to ensure compliance with a given standard. If the audit fails, that is to say that the configuration is no longer compliant with standards, then what I do is I associate an assembly to the node. An assembly is a collection of network features. In this particular example, this assembly will provision NTP, SNMP, syslog, DNS, the base features on a device, which actually matches the audit policy. So the audit policy is auditing those features, and the assembly is a collection of those features that the audit policy is checking. And after this assembly has been associated, we want to provision the device. This will restore the configuration back to its last well-known good state. So now let's create an event that is going to trigger this workflow. I have already SSH'd into leaf 101 here, the leaf that we're targeting for this exercise. And so the first thing that I want to do is to evaluate the configuration that I want to modify. So I'll do a show run pipe section NTP, and that will tell us the configuration as it sits on the device today. Now, this is actually compliant with the given policy. So what I'm going to do is I'm going to take this configuration element, this line out. I'm going to enter the terminal, and then I'm going to remove that command. And then I'm going to end my terminal session, my configuration terminal session. Now, what has happened here is that Splunk has received an alert from that device, a syslog message. And that syslog message says that, hey, the config was modified, or somebody entered the configuration terminal. And the given host that did that was Leaf 101. And what we have done now is we can look at Gluware, and here in the running workflows, we will see a workflow pop up within about 30 to 60 seconds. It usually takes about 30 to 60 seconds for Splunk to process the alert and to trigger the Gluware workflow via that API call that I showed you earlier. So the workflow is now running, and we can inspect the log and follow along. So we're first taking a snapshot of the device. Running an audit policy. Because drift was detected, obviously, we've associated the assembly with the node, and now we are provisioning the node. Now that the workflow has completed processing, we can come back to the device and inspect the configuration by rerunning the show command that shows us the NTP section of the configuration. And you'll note that the configuration is now as defined by policy. Well, as you can see, that's a pretty effective workflow at ensuring that a device's configuration complies with standards. Now, there are a couple of things that we have to build out in this workflow that we orchestrate. One of those is an audit policy. And an audit policy is a collection of rules that audit a specific configuration. And so we can accelerate the creation of these audit policies, which used to be a little bit more time consuming and required basic to moderate knowledge of regular expressions. And we can use Gluware TitanAI to do that today. So for that, I will go to my Gluware Copilot, and I will paste in this prompt that I have prepared. And as with all AI, the better the prompt, the better the results. So I'm going to be really specific about what I want here and send that message. Now let's maximize the window and note what I've asked it to do. I have asked it to create an audit policy that ensures a device's configuration contains the following snippet. I tell it that the third octet of the IP address may be something other than 10. The other octets must match. And so I then provide a sample configuration, and I tell it to name the policy AI NTP server policy. And so it's been thinking here for a little bit and is now generating the policy. And you'll note again that it's a collection of rules in JSON format. And looks like we are done. And so what we can do is we can take this audit policy and copy it to our clipboard and then save it as a JSON file. And then in config drift and audit, which is where I am, audit policies, I can import the policy. And there we have it, one successful import. And here it is with 3 rules. And as you can see, let's close the Titan window, it's accounting for variability in the third octet of the IP address with a regular expression. Now that we have an audit policy, the next step is to create a config model editor, network feature, and related instances. Now, to do that, once again, I'm going to use Gluware Titan Copilot. So I'm going to maximize this window, and once again, I've prepared a prompt that I'm going to paste into the AI. And what I'm asking it to do here is to create a config modeling network feature that provisions NTP. I tell it that I want an array of NTP servers and that this array should contain a field for IP address. And I also provide an instance of what I think that model should look like. I tell it to use Liquid.js in the CLI instance and to give me NXOS and iOS XE versions. The first NTP server should be preferred. It should support NXOS and iOS devices. And then I provide the JSON that I'm looking for, the final instance, and I also tell it what the end result CLI should look like so that it can properly create the necessary instances required for this provisioning model. And so we'll let it think here for a second. And in about a minute, we'll have all the required instances created. And so as you can see, it's generating the results now. And we are done apparently. So let's see how we can put this code into a configuration data model in Gluware. So the first thing I'll do is I will copy the feature definition and then go to my Gluware Lab IDE and replace this code here with my new form. And that is the form that the AI created for me. And as you can see, we can add NTP servers. And we have our data model ready. This concludes our demonstration of a Gluware workflow that was built to enforce configuration standards on network devices. For more information on this and all things Gluware, please visit gluware.com. Thanks for watching.